Hello, it's Daniel here. Welcome to A-level lesson on redox chemistry. This is just an introduction to the topic. There will be some follow-up videos coming up soon, which will go further into each different aspect of redox. But this lesson is just going to provide a brief introduction into what it is and a way to think about it in terms of understanding the concepts that are going on. And from this lesson, it will then lead into the sort of tools that you need to use and how to create half equations, how to combine half equations, and all of the other business that goes on with redox chemistry. So first of all, first thing, redox is short for reduction and oxidation. And a lot of chemical reactions are redox reactions. Reduction means to gain electrons. Reduction is gain. Oxidation means to lose electrons. Oxidation is loss. And one way to remember that is a very well-known mnemonic, which is oil rig, O-I-L-R-I-G. Oxidation is loss. Reduction is gain of electrons. So what does that mean? That means in a redox reaction, you have got one of the reactants losing electrons and you have another reactant gaining electrons. So there's a transfer of electrons between reactants to form the products. Now in a chemical equation, when you look at a chemical equation, any chemical equation, you won't see the electrons. You see them in a half equation, we'll come to those later, but in a chemical equation itself, you don't see any electrons. So what's going on? How do you tell that a reaction is a redox reaction? Well, here you need some sort of a tool to help you. And chemists have developed a tool called oxidation number, also called oxidation state. Now, oxidation number and oxidation state enables you to keep track of the electrons that each atom within each reactant has, how many it has, and therefore how many it's gained, how many it's lost, as a result of what it's doing and who it's bonded to, and as a consequence we can see from oxidation numbers and how they change what's happening to the electrons. So in order to be able to understand redox and understand what's going on in redox reactions, you need to be confident with oxidation numbers. So what are oxidation numbers? Well, you need to know a definition for them. You need to know this definition off the top of your head. So first of all, the first key part of it is the oxidation number is the number of electrons that an atom has gained or lost as a result of bonding. So if we take ionic bonding, for example, and you think of, say, an atom of sodium, when it is bonded ionically, it has lost an electron. It has formed a 1+ ion. So its oxidation number is +1. Okay, so oxidation number, the charge comes first and then the value of the charge, so plus followed by 1. If you're talking about the actual charge on the ion, you'd say it was 1+. And that's to distinguish oxidation numbers from the charges on the ions themselves. The oxidation number of sodium, the sodium 1+ ion would be +1, i.e. it lost 1 electron as a result of bonding. And similarly, take the chloride ion, it would be Cl would have an oxidation number of -1. Just like its charge is 1-, its oxidation number is -1. So for ionic bonding, oxidation number is very closely linked to the charge, especially for simple ions. But what about covalent bonding? So yes, there can be a loss and gain of electrons in covalent bonding, but it's not a total loss, it's just a partial loss. So take, for example, covalent bonding in water between oxygen and hydrogen. The oxygen is more electronegative than the hydrogen. So in the covalent bond between the oxygen and the hydrogen, the two electrons are shared, but oxygen has the electrons closer to itself. it is more electronegative, has more protons in its nucleus, it's pulling those electrons closer to it in the covalent bond. So we would say in water that oxygen has partially gained 2 electrons. It would have an oxidation number of -2, indicating a partial gain, in this case because it's covalent, of 2 electrons. Hydrogen, each hydrogen has partially lost 1 electron, so the oxidation number of each of the hydrogens is +1, indicating the partial loss of 1 electron. So in summary, oxidation number is a tool used by chemists to track the number of electrons lost or gained, or partially gained as a result of bonding, and as a consequence of assigning oxidation numbers and tracking them in a chemical reaction, we can see what's been reduced and what's been oxidized. We can recognize a reaction as being a redox reaction or not, and it becomes a very powerful tool to enable us to create half equations, understand what is going on with them, be able to combine half equations, be able to balance redox reactions, and so on. More of that to follow. So I hope that's been a helpful introduction to redox chemistry. Remember, reduction is gaining electrons, oxidation is loss of electrons, and oxidation numbers are a tool that chemists can use to work out what's going on. More on oxidation numbers, more on redox chemistry to follow soon. Thanks for watching.